So, I've heard that it's impossible to get above 90% accuracy on the MNIST dataset. Might have been 95, but I want to know why. So, let's just torch. How do I even get the dataset? Oh, fun. I can just steal code because naturally, what else would I do? Yeah. Well, I need MNIST, not fashion MNIST. Okay, let's see what happens. I feel like there's going to be a lot of waiting. I don't have a GPU. Is it done? Oh, it is done. That was fast. I guess another thing I should do is make a network to train it. And that's great. Help. Oh, that's even worse. I don't want to do math. And it's broken again. This stop. Oh. Okay, well, now what? Okay, now we need to train the thing. We can just do some copy paste. And it's broken. The extent of my laziness is not measurable. Train data load. I literally have that. No, I don't. You know what? Just do some more copy paste. Oh wait, they even made one here. I can just use this. Now we wait. So that's 84. We're supposed to be at 95. So what is the logical next thing to do? Okay, let's change this stuff. I highly doubt making the network smaller would help, but what are you going to do? Learning rate. Oh, stochastic gradient descent. Isn't the normal thing like atom? There is an atom. So there is params, learning rate, and betas. Params, learning rate, and betas. Let's try this again. Run everything because I don't know what I'm doing. That looks not bad. Test error. Look, it's already 91. I was right. The network, I made the network smaller. Anyways, okay, so while that's going, we can figure out the visualization thing. Because I have a feeling that stuff is not classified correctly in the dataset, which is why you can't get above 95. So we can probably just copy this. Yeah, that'll be fine. Is this done? Nope. Hey, look, 94. All right, so let's do this. 85003. That's whoever made this had really bad handwriting. Okay, so let's modify this a little bit. What we can do is we can pass the image to the network and see what happens. So y equals model image, and then print y. What can go wrong? Let's do y.argmax. That'll probably be better. 591. Oh wait, this is right. Cool. Okay, so that means we are classifying it correctly. 727769. Okay, so now we just need to find one that's not classified correctly. So out of all the dumb ways to do this, I could just click enter until something bad happens. Oh, there we go. 3. Well, I found one. That's a horribly written 2. I thought that was a 7. Maybe the 95% thing is just because people have bad handwriting. Anyway, so this 3 is not supposed to happen, so that means let's run this again. And we wait 5 hours, and then let's see if we can improve the accuracy. So it's a little bit better. We got to 94.9. So let's try this again. That is a horribly written 3. Whoever... Okay, well... That is not right. You cannot tell me that is a digit. Forget 7. Okay, now... How did the network get that right? Anyway, we keep looking. Alright, so I've clicked enter around like 20 times now. And nothing's come up. So what I'm going to do is I'm going to say if label is not equal to y.item, then print wrong. This should just let me spam the enter key. Oh, okay, we've got one. Which one? This. I can see the semblance to a 0, but I can also see the 5, and is there a way to improve the network so that it doesn't do that? We're gonna use some encoder, decoder, what was it? Self-supervised learning. Okay, so now what we'll do is we'll make an encoder, or yeah, it's encoder, decoder, whatever, encoder. So all we need to do is we make the whole thing encoded into 16 numbers. So, okay, so that's the encoder. Now we just need the decoder, which makes it big again. All right, so now we just need to make everything train to itself or something like that. So let's steal this again. Okay, then test loop, we don't need a test loop. Now we do this. So now this should be square loss, if that's a thing. Hope that's a thing. Optimizers, we have 2 optimizers. The first one is the encode parameters. The second one is the decode parameters. Square loss is not a thing. Great. Now what? How do we find a square loss? It's called MSE loss. Of course it is. Lots of debugging. That worked. Okay. So let's try that. So while that's going, we can now visualize it. Well, okay, it might be useful to know the shape, but then we need to wait for the thing to finish. So finish training. I cannot tell if it did well or not because the loss is exactly the same at the start and at the end. But what do you know? How do you plot things? Okay, so what we need to do is we need to reshape. Well, do we need to reshape it? We don't need to reshape it. So all we need to do is say image equals decode encode image. And now we reshape it like this. And moment of truth. It's absolute crap. Now, why is that absolute crap? Encoder. Oh, because I didn't train the decoder. Well, now we're going to have to wait again, but at least we found the issue. So, that worked well. It's kind of blurry, but I think that's fine because we don't actually need these images. I mean, like, MNIST was already bad enough. Like, looking at that handwriting, Jesus Christ. But what we can do is we can use this decoder, no, not the decoder, the encoder to train the network. So when we predict, we first pass it through the encoder. And then we directly pass it through our new little thing. So now, hopefully, what this will do is use everything from the decoder, like the image regeneration thing we've done, and break itself. I don't have a good feeling about this. Okay, so I trained it 3 times. I've been sitting here for I don't know how long, but it's at 95. So let's try this thing again. And hope that it works better. Okay, we have the wrong thing. So I'm just gonna keep doing this over. Oh, I found one. I found one. That's clearly a 5. Okay. Well, the previous one was clearly a 5, but whoever drew this one, you need a you I feel bad for like when you go to math class and you do a test and then the teacher sees this. Anyway, okay. Well, let's see if there are any more. Oh, okay. Well, that's not a 4. That really isn't a 4. So, I guess the solution, the answer to the question is we just suck.